Getting the best from Chemistry Explained needs you to participate. So write notes, complete tasks on paper or tablet. Pause and control the pace at which the lesson goes. Crucially, complete the tasks when prompted. That means pausing the lesson, taking your time, thinking the problem through. Only when you're ready, continue. Correct your work before moving on to the next slide. Organic synthesis. So within organic synthesis is practical skills. So I'm going to start with heating under reflux. Please pause and draw apparatus in a reflux arrangement. A reaction mixture undergoing reflux. Please label the important bits of apparatus and also comment on any hazards and their reduction of risk. So I'd like to do that now. Okay, so assuming that you've finished your diagram, here is a diagram of a reflux arrangement. We've got a vertical Liebig condenser, a round bottom or pear-shaped flask. Anti-bump granules, did you include those? Anti-bump granules need to be included. They reduce the vigour of boiling. Heating mantle, other heating methods are acceptable, except of course that heating mantle does reduce the risk of fire. Water in and water out. Water in at the bottom, water out at the top. So could you think of some examples of syntheses which you have undertaken and which have used the reflux arrangement? Think about it, pause the video, think about it, write a list. Okay, so the examples that you are expected to recall would be the oxidation of primary alcohols to carboxylic acid and the dehydration of cyclohexanol to cyclohexene. The second practical method used in organic synthesis is certainly distillation. Could you draw the apparatus set up for distillation, labelling as the important bits? I'd like to pause and do that now. Okay, so distillation apparatus is that type of setup. By the way, A-Level 2022 had a 3-mark question, draw an apparatus setup. So how does it differ from the reflux condenser? Well, we've got a thermometer opposite, if you notice, the side arm. You've got a horizontal or near horizontal Liebig condenser. You've got a collection vessel that is generally cooled and iced in an ice water bath, for example. So before we move on, could you pause and list some examples of organic syntheses or processes where you have used distillation? Okay, so certainly the immediate distillation of an aldehyde when oxidizing a primary alcohol, and of course probably you won't have done it in this context, but redistillation of a purified organic liquid. The final stage in the purification of a liquid is actually to distill it once again. So that's the overall process. Because of time, often in schools you don't get to that stage, but you need to note it. So if we've talked about the final step in the purification of a liquid, then we need to talk about the earlier steps, the first one of which uses a separating funnel. Can you draw a separating funnel and perhaps indicate how it would look, what it would look like in use? Okay, so separating funnel looks like this. We've got two levels, two liquids in my diagram. I hope you can see I've got a bluish upper liquid and a greyish lower liquid, and I'm collecting, of course, the lower greyish liquid. The lower layer is generally the aqueous layer, because organic liquids tend to be less dense than water, so the general procedure is to retain the upper organic layer. As indicated here, you need to remove the stopper to allow the flow of liquids. It's a common error to leave that in, and the separating funnel doesn't seem to be working. So after an initial use of a separating funnel to separate out an organic liquid from an aqueous layer, you would need then to dry the organic liquid. So here you use drying agents. I wonder if you could pause the video and list some drying agents that you are aware of or have used. Okay, so the key point about using a drying agent is that you add a small quantity of solid to the organic liquid. So I'm indicating a small amount of solid here with my 3 crosses. The extraction of water is not immediate. You need to leave it for some time to be effective. And then you decant. So the word decant is sometimes not known. You're tipping away the liquid and collecting the liquid, leaving behind the solid in the original container. So that is called decanting. So you decant the dry organic liquid. So examples of drying agents would be anhydrous magnesium sulfate and anhydrous calcium chloride. So the purification of a liquid, step 3, as mentioned earlier, is redistillation. So exactly the same distillation setup, but of course you're going to collect at the boiling point of the desired product. So you know the product that you're looking to collect. The database will give you its boiling point, so you collect at that boiling point. If, however, there is no sharp boiling point detected, or liquid is collected at a range of boiling temperature, that would indicate impurity, and you would need to repeat the distillation or redistillation process. So an important aspect of synthesis is obviously the reaction pathway or synthetic route. So just as a preamble to that, you need to be aware that organic molecules may contain more than one functional group. So for example, the molecule here, could you identify the 2 functional groups? And the molecule here, could you identify the 3 functional groups? So if I run through those for you, make sure you've made your best attempt to identify them. Okay, so this is an alkene group where my pointer is indicating, and this is a carboxylic acid or carboxyl group. We would describe this as a haloalkane. This group here is a ketone, and here we have a secondary alcohol. So you need to be able to identify functional groups, of course. So where there are more than one functional group within a molecule, provided that they are at some distance and not interfering with each other, the reactions of each functional group is retained. So we can use that in a synthetic route. to achieve or obtain a target molecule. So a synthetic route would be a series of reactions or a reaction pathway that takes us to a target molecule. However, the starting material will determine the reaction pathway is possible, or indeed whether the reaction pathway is possible to the target molecule. So we have a target molecule and starting material. For example, we might start with bromoethane, and our target would be ethanoic acid. Could you pause and fill in the missing intermediate molecule and the two steps, the step from bromoethane to the intermediate molecule and the step from the intermediate molecule to ethanoic acid? Could you list the reagents and conditions? Pause, think it through. Okay, so returning, we've got an intermediate molecule, which you may have realized would be ethanol. So how do I go from bromoethane to ethanol? Aqueous sodium hydroxide and warm. So we've formed ethanol, and how would we go from ethanol to ethanoic acid? Well, that's a classic acidified potassium dichromate and reflux. So you would be expected to know all of that detail to be able to go from the starting molecule to the target. You'd be expected to identify a suitable intermediate and then identify the reagents and conditions needed for the steps between the molecules in your synthetic route. So here are some synthetic pathway problems. For instance, propan-1-ol to propan-2-ol. Can't be done in one step, must go through an intermediate molecule, which means there is a step from propan-1-ol to the intermediate. The intermediate undergoes a second step to propan-2-ol. So for all 4 examples, could you suggest an intermediate molecule and suggest reagents and conditions for each of the steps? Pause the video, work your way through, and come back when you are ready. Okay, so if we look here at the first one, if I do the first one as an example, so propan-1-ol, we would go to propene. So I won't draw in the hydrogens, let's do those as dashes. So we would get propene. So propan-1-ol to propene, and then from propene to propan-2-ol. So this would be concentrated sulfuric acid. And 170. And then the second step, I prefer to use phosphoric acid, concentrated phosphoric acid, and of course steam or water above 100 degrees Celsius. So that will take us from propan-1-ol to propan-2-ol. Now, I'm going to suggest that if you haven't done the other 3, can you attempt the other 3? Come back when you're ready. Okay, so propan-1-ol to to 1,2-dipromo-propane. Again, we're going to go through propene, and again, it's going to be concentrated sulfuric acid, 170. And this time we're going to add bromine at room temperature, so room temperature and pressure. So we would get the addition of bromine atoms across the double bond. If you're ready to check the third one, I will take you there. Again, we're going to go from propan 1-ol to propene. So you'll see there's a pattern to these things. A lot of the synthetic pathways are repeated. And here, instead of bromine, we're going to add HBr again at room temperature and pressure. Hydrogen bromide will give us 2-bromopropane, according to Markovnikov's rule, of course. And how are we going to go from propene to propanone? Well, we need to go via propan 2-ol. So this would be concentrated phosphoric acid, steam, and this of course would be dilute sulfuric acid and potassium dichromate, and we would need to reflux, fitting it in the bottom there. So you need to know those and problem solve. You can't problem solve without a thorough knowledge of all the reactions on the OCR specification. Okay, so let's do another set of problems. 1-bromopropane, 2-propene, etc. Take your time, pause the video, think it through carefully, look at your notes. Don't search it on the internet, please. You're wasting your time. Search through the notes that you have, textbook or whatever. Solve the problem of how to go from 1-bromopropane to propene. Come back and look at the answers when you are ready. Okay, so the answers are for 1-bromopropane to propene is that we need to go via propan 1-ol. So that's going to be sodium hydroxide, aqueous sodium hydroxide, and we'll warm it, and then to go from propan 1-ol to propene, it's going to be concentrated sulfuric acid, and I believe 170C is acceptable, or heat. Okay, I'm going to go through propan 2-ol to polypropene. Again, we're going to go through propene to make polypropene. That's fairly obvious, I hope. So how do we go from propan 2-ol to propene? It's concentrated sulfuric acid, 170, and this will be some sort of catalyst and then some sort of high temperature or pressure. So some combination of a catalyst with high temperatures and pressures will turn propene into polypropene. Ethene to ethane 1,2-diol. Well, we need something that can go into ethane 1,2-diol, so we'll have 1,2-dibromoethane. So we achieve ethene to dibromo by reacting with bromine at room temperature and pressure, and here we're going to substitute hydroxide ions for bromine atoms. So sodium hydroxide, aqueous and warm. The final one, 1-bromopropane to propanal. Well, propanal, we're going to require propan 1-ol again. It's a little bit repetitive, I hope you're seeing. Once you've done a few of these, the patterns keep repeating themselves. So propan 1-ol, how are we going to go from 1-bromopropane to propan 1-ol? Well, hang on, we've done this already on this page. Aqueous sodium hydroxide and warm. And then from propan 1-ol to propanal, obviously acidified potassium dichromate and immediate distillation. So a thorough knowledge of all the reactions in the specification are required. You then problem solve by linking them together in different ways. However, you can see that certain patterns emerge and repeat themselves. So if you're not too sure, go back and just repeat this whole exercise of the last 2 slides and repeat it again. Repetition is an important feature in organic chemistry. So for my final slide, just the obvious statement that to consolidate you need to practice, you need to find problems from whatever source you have available to you, but those sources which have comprehensive answers are the best. So attempt the problems, check your answers. Move on when you are being consistently accurate and complete in your answers. Choose the next topic that you think for you is the one you need to focus on.